Every letter you're reading right now carries a secret meaning your brain knows, but you don't. The letter O feels round and large. The letter I feels thin and bright. And this isn't just psychology. It's a hidden pattern that just shattered over a century of linguistic theory. A team of researchers just did something unprecedented. They mapped every single letter in the English alphabet across 9 dimensions of meaning: size, shape, brightness, texture, speed, temperature, pleasantness, weight, elevation. Not some letters, all 26. What they found changes everything we thought we knew about how language works. The paper, beyond Bouba, Kiki, multidimensional semantic signals are deeply woven into the fabric of natural language. Translation, individual letters aren't meaningless building blocks. They carry systematic semantic information that runs through the entire structure of language. Here's what's at stake. For over a century, linguistics has rested on one core principle: sounds are arbitrary. There's no reason dog means dog. We could call it bluff or zephyr. This randomness has been foundational to how we understand language itself. But if sounds are truly arbitrary, how do children learn thousands of words at lightning speed? Why does teeny instantly feel smaller than enormous, even before you know their definitions? Why do certain brand names feel exactly right, while others feel completely wrong? The researchers went systematic like no one before. They built 4,427 pairs of nonsense words differing by exactly one letter. Brave versus brove, keng versus kong. That covers every possible letter contrast in English. Every way 2 letters can differ. Then they unleashed 3 AI systems as meaning detectors. GPT-4, Claude, and Gemini independently rated every fake word on those 9 semantic dimensions. Picture an AI deciding whether flim feels bigger or smaller than flom, rougher or smoother, brighter or darker. It's like using metal detectors to scan every inch of a field, but for meaning hidden in letter combinations. The result shocked everyone. Every letter showed a distinct semantic fingerprint. The pattern was so clean that just 2 mathematical components captured 87.6% of all variation across letters and meanings. But AIs could be reflecting weird training data, right? So they tested humans. When people chose which nonsense word felt bigger, brighter, or heavier, they matched the AI predictions 80.8% of the time. Pure chance is 50%. Then came the ultimate test: 5 completely different languages: English, Spanish, Japanese, Mandarin, Arabic. Different writing systems, different sounds, different language families entirely. Above chance performance across every single language. 73% to 84% accuracy. Here's the smoking gun. They traced these patterns directly to mouth mechanics: tongue position, lip shape, vocal cord tension. The physical properties linguists used to classify sounds predicted the semantic profiles with stunning precision. The logic is elegant. Sounds requiring tight, constricted mouth positions feel small and sharp. Sounds needing open, expansive shapes feel large and round. Your vocal tract's physics directly creates meaning associations. This explains everything we've been missing. Why little contains sounds that feel tiny, while huge contains sounds that feel massive. Why certain product names instantly communicate their purpose. Why some words stick in memory while others vanish. The implications run deep. If individual sounds carry systematic meaning, then language learning isn't about memorizing random sound meaning pairs. Children might be detecting coherent patterns woven throughout language from their very first words. But here's what still puzzles researchers. 2-letter combinations showed effects up to 60% stronger than single letters, suggesting these meanings build on each other. Yet we still don't know how sound-level semantics compose into whole word meanings. That mystery remains unsolved. What we're witnessing is the collapse of linguistics' most fundamental assumption. Sound meaning connections aren't occasional curiosities. They're systematic architectural features of human language itself. So next time you're choosing a name for a business, character, or concept, how will you navigate these hidden semantic dimensions that every letter secretly carries? This video was generated using AI summarization of the source paper. The analysis and commentary represent an AI's inference from the study, not the author's conclusions or intentions.